Hello, this is the lesson 3 of module 1 of the EngageNY Algebra I curriculum. This is kind of our first introduction to what an exponential function looks like on a graph. So exponential functions are hugely important in so many things. Not only do they show things like what we're going to look at here, like bacteria growth or decay, population growth or decay, they're so useful. And it's exciting because it's the first time that we are going to be able to see them and see how they compare with linear and quadratic functions, which you learned about in lessons 1 and 2. So to start, your instructions were to look at this video, and this was on the class website. So watch the graphing, or watch the story shown in this YouTube video, and basically it was just kind of a gross looking bacteria multiplying in a petri dish, right? So we were looking at these bacteria multiplying, or basically, honestly, they were dividing in half, which multiplied the number of bacteria you saw. And what I asked you to do was to record how many bacteria you saw after every second. And after a while, that got kind of difficult. So as you can see, I did that, and we'll talk about how it's sped up a little bit later. But basically, after a certain number of seconds, you could count. So it started off easy to count, and then actually very quickly, 4 seconds was honestly all that I could do. I kept losing count, but we should be able to see a pretty good pattern here. So we started the video with 2 bacteria, and after every second, and it says sped up because for every second, I think the narrator in the video said every second in the video represented 20 minutes in real time. So, and we'll talk about that a little bit later. We'll change what our scales are on our graphs. But for now, we've got, after 1 second in the video, notice, how do we get from 2 to 4? And after another second went by, how do we get from 4 to 8? How do we get from 8 to 16 in another second? And then from 16 to 32. And then we're actually going to estimate, even though I wasn't really able to count them, and you probably weren't either, how is this changing? So notice we can't jump to graphing right away because I'm missing my scale on the y-axis. So I think let's try to figure out how high my scale needs to go before we start plotting points. So we're starting low. We're definitely going to want to start, of course, we're going to start at 0 because we're starting here close at 2. How are we getting from 2 to 4? How are we getting from 4 to 8? And all of these are going to be following the same rule. And most of us have already kind of figured out, 2 to 4 to 8 to 16 to 32 and so on. This is a pattern of multiplying by 2, right? Or multiplying by 2, and so on. And this is a feature of exponential functions. If you are increasing, so kind of like linear functions have a slope, similarly, exponential functions, while you're still growing at a specific rate, you're not adding to get to your next value, you're actually multiplying, right? So, and usually we'll use words like doubling or tripling or something like this. And in this case, our bacteria every second is, and I even told us earlier, it's doubling. So when we look at this, let's actually, so I don't just want to go to 4, so let's go, I want to graph up to 6 seconds, okay? So we're going to kind of figure out how many bacteria we're going to have after 6 seconds. So if at 4 we have 32, we figured out our pattern, we're multiplying by 2. At 5 seconds, I should be, if we're following our multiply by 2 pattern, I should be, and I ran out of room here. So I'll come over here. So after seconds, and then number of bacteria, if we've got 5 seconds and we're doubling, so 32 doubled, give us 64. And then if I want to go up to 6 seconds, we're doubling, we should be at 128. So this is why they didn't give us a scale, okay? We're going, and think about how quickly this is. So this is another feature of exponential functions. We went from 2 to 128 real fast. So exponential functions, you will be noticing, and of course it depends on what your factor of growth is, but you might be noticing, or you're a lot more likely to be noticing, a very rapid increase, or in the case of exponential decay, very rapid decrease. Okay, so let's start graphing. We need a scale. We need to go all the way up to 128. So let's maybe count by, we can probably do 20s, 20, 40, 60, 80, 100, 120. Yeah, sure. We can count by 20s. So if you want to pause, or not, 100, 120, I'll go up to 140 for good measure. And yeah, actually go ahead and pause, and when we come back, I will have my graph here for you to compare with your own. So as you can see, now that we're back, take a look at this graph. And as you can see, we start really, really small. So our scale was counting by 20s. And notice it's really hard to tell where each of these are because my graph isn't very large. But we're starting really low, and then all of a sudden, we are skyrocketing, right? And you'll notice not only is the amount doubling, look at the graph itself. The space between each point is doubling as well. So the distance between points at 5 and 6 are actually twice as large as the distance between points 4 and 5. Okay, so that's where we're seeing that doubling. But yeah, so this is the general shape of an exponential growth function. And it's kind of starting, it's a smooth curve, and then it's gonna kind of shoot up. It's gonna look almost vertical, but it's never really gonna quite be vertical, because then of course it wouldn't be a function. So when we notice something grow really, really fast, think back to, what is slope? It's that rate of change. The faster we're changing. So as we continue on in an exponential function, the faster we're changing, the steeper our slope, and it's gonna get steeper and steeper and steeper until it looks almost vertical. So in the next part, now we're looking, well, this was a sped up version, right? So the video, it was time, but it wasn't real time, right? So because the video is describing every second was 20 minutes. So let's actually put this into a graph that we can use as real time, okay? So we're gonna be counting minutes, and notice that we're if every second's 20 minutes, we need kind of a little bit larger scale. So let's just translate exactly what we have here, but instead of using the video seconds, we're gonna use real time. It'll go 0, 20, 40, etc. So let's make our table. And I'll make it a little smaller so we can all fit this in. So we've got real time in minutes, and then we have number of bacteria. So if we've got real time in minutes, we've got our number of bacteria. Of course, it's still gonna start with 0, 2. So we started with 2 bacteria regardless of how we're counting. But now instead of 1 second, that is the same thing as 20 minutes in real time. This number's not changing. These are just, we're using different amounts of time to describe the same thing. So you'll notice your Y values, your number of bacteria, are gonna be the same. So after 20 minutes, real time, we have 4. After 40 minutes of real time, we have 8 bacteria. 60, notice I'm going in increments of 20 minutes. We have 16. So this is our hour point, right? 1 hour, because we know that's 60 minutes. We are gonna go up to, I may have made this a little too large again, and that's okay. I'm gonna pause the video, and I want you to go ahead. So I'm where we've stopped. I actually want you to continue on. Notice that this says 300 minutes. I want you to continue on until you get to 300 minutes. So if you need to restart your table next to us, that's fine. Or next to this existing table, that's fine. But I'm gonna pause the video and I want you to pause as well and take some time, continue doubling these values while every 20 minutes, because that is what's happening in real time. So compare what you get to what I get when we come back. So we're back. Notice, I apologize for my small writing. Hopefully we can zoom in enough that you can read that. But basically, I wanted to kind of fill up this graph just to see, yes, it took us a long time to start. I mean, we were growing pretty rapidly overall, but look at our scale on our graph. We had to go from 0. Notice I counted by 7,000s here, and yes, I did go ahead and put all of these values on the graph. And as you were making your tables, you should have been noticing, man, once you start gaining ground and doubling numbers, you really increase very quickly when you're growing by a multiplication factor instead of just adding the same amount like you would in a linear function. So again, look at how these values translate as to being onto a graph. We had to make our scale so large. So this is about as big as I can make it. I counted by 7,000s, and notice it seems like we're not really doing a whole lot. Yes, we know that we're growing, but in the grand scheme of things, it's like, man, we're really staying still. But once you start gaining ground and doubling, man, you double really quickly. And your population, of this case of bacteria, your bacteria population is really rapidly growing very, very quickly. So even though it looks like you're not doing a whole lot to start, you really skyrocket once you start gaining ground, and you can see that in our numbers. It really didn't, yes, this is kind of a long table, but I mean, going from 0 to 300 minutes, we went from 2 bacteria to 65,000 bacteria in just, and I counted by hours here, in just 4 hours. So kind of in the same, we went from sped up time to real time, and then we're gonna make one more little tweak to our graph here, because normally we don't really count minutes as saying, usually I don't say, after 240 minutes, I would normally just say, after 3 hours. So that's the last little change to our graph that we're gonna make, is we're actually going to just count by hours, because, we're growing so quickly. Let's count by hours and see how many thousands, we're gonna get up to eventually 65,000 bacteria in 4 hours. So let's just kind of see what that looks like on the graph here. So I'm just gonna go, and notice I already marked it on my other table here, but I think the best way to read this is gonna be explaining how these bacteria are growing in real time using units like hours, because we're counting for so long. So if we look, we're counting by hours. So I'm just gonna make a table. And again, nothing's really changing. I'm just changing how I'm counting. So our information is still all the same. Instead of saying 60 minutes and counting by 20-minute intervals, I'm just gonna count by hour intervals and look at every 60 minutes. So we've got time now in hours. We still are counting. Our number of bacteria is gonna be exactly the same. This table is gonna be a lot smaller though. It's only gonna have 4 slots because I'm only going to 4 hours. So number of bacteria. Of course, when we start, again, those are points that are always the same. We still have 2 bacteria. After 1 hour, I'm gonna go find that spot. I had 16. After 2 hours, now I jump to 128. And after 3 hours, so add 60, should be here. I had 1,024. And then 4 hours, whoop, switch that up. because I counted wrong. Hello? 4 hours and 5 hours. My fault. I'm just testing you. Just kidding. I really made a mistake. Okay, so 4 hours, we've got 8,192 bacteria. And again, I apologize for my graph, my table making skills. I should have been doing this in a notebook or something. I've got 5 hours. 300 minutes is 5 hours. That makes a whole lot more sense. 65,536 bacteria after 5 hours. Your scale honestly could be about the same. So if we're going up, and notice I'm using K because I'm lazy instead of 1,000, 3 zeros. What am I doing? Just counting by sevens. Because again, my Y values did not change from my table. I just trimmed some of them off to more accurately, if I'm counting for this long, if I've been counting for 300 minutes, chances are I will be describing my length of time in hours. So this is just really, the only reason we've been changing graphs so far is like figuring out which units are most appropriate, which is important, especially when you're recording data of any type. So we've got 1 hour, well, I'm sorry, 0. We started with 2. I'm gonna put that right here, right next to 0, 16, unnoticeable or not noticeable on this giant scale. Still got 128, 3 hours, maybe seeing a little bit of an increase here. Now finally after 4 hours, now I'm seeing that increase. 8. Notice I'm estimating since my graph is so small, my scale is so large. And then finally after 5 hours, look at this. Now we're way up here. So that's really the power of exponential growth, is even when not a whole ton of time has passed, if your factor of growth is doubling, imagine if this were tripling, right? So exponential functions, they've got this shape, kind of a slow curve to start. Yes, I'm increasing just a little bit, and then boom, you're skyrocketing. Slow increase, or seemingly slow, even though our numbers are pretty large. Increasing just a little bit, and then all of a sudden we're increasing really rapidly. So this was our first real introduction at what exponential functions look like. And thank you so much for watching.